So this is the last, guys, this is the last section we have, 1.9 for exponents, okay? That crew from last year had trouble with it, but I think you guys are going to be okay because I look at some of those names, and anyway, you guys will be all right, okay? Except for that Elijah guy who's up there, but oh no, he's here this year. So and Egypt, so we've got. So anyway, so no, I was just talking about the crew from last year, which is on this list, had trouble with this, and then I look and say, well, 3 of the names up there are actually this year's people. So I was just trying to pick on you. So okay, guys, let's move on. I should not have distracted you. So 2 to the x equal 4. What's the solution to that equation? 2. Why is 2 the solution? Because 2 squared is equal to 4. Now, what's different here is, how is this equation different than the ones we've seen before? Where is our variable? It's in the exponent, okay? So that's what's different about today. We're still in exponents, but everything we did yesterday, we had x to a power, x cubed, x to the 2/3. Now, the exponent is my variable. So there are a few little nuances in how we solve that equation. Now, 2 to the x equal 4, that one's pretty easy. Let's solve the next one. 2 to the x plus 1 equal 1/2. Now, the only way in this class, at this level where you are in your mathematical journey, that you can solve this is if you can get both sides of the equation as the same number raised to a power, okay? So on the left, I see what number raised to a power? 2. Is there any other way to simplify 2? I mean, no, it's not 4 squared. It's not 5. It is 2. It's 2 times 1. It's a prime number. That's all I can do. Now I got to ask myself, can I write the right side of the equation as 2 to a power? Yes. So someone tell me, what is it? Not 2 to the first. 2 to the what? Negative 1/2. Negative 1, sorry. So if you remember, 2 to the negative 1, that's 1 over 2 to the 1, which is what? 1/2, okay? Now, what you are accustomed to doing in this unit is me giving you something like this and telling you leave what? No negative exponent. So you're used to going from here to here. Now you got to be able to look at this and go back to here, okay? So 1/2, I can write this as 2 to the x plus 1 is equal to 2 to the negative 1. Does everyone agree with that? Okay? 2 to the negative 1 is 1/2. Now when I look at this equation, do I see the same number on both sides raised to a power? So if 2 to the x plus 1 equal 2 to the negative 1, what do you think is the relationship between those two exponents? They're equal. So you guys are right on top of it today. So x plus 1 is equal to negative 1. What is x equal? Negative 2, okay? So that's the way all of these problems will solve. You need to get both sides of the equation. It's the same number raised to a power, and then you set the exponents equal to each other. Now, what if we had this problem right here? 2 to the x equal 3. Okay? On the left, I've got 2 to a power. Can I write 3 as a power of 2? I can, but it's not an integer power. It's not 2 squared. It's not 2 to the negative 1. This is beyond the scope of this class. This is next year's problem in pre-calc. So you'll have to use logarithms to solve this one. We're going to get there where all the ones we can solve do not require that extra skill. So, yes, we will skip there because I'm teaching that to seniors. They're struggling, so we're going to just skip past that word and go forward. So, solve the following exponential and power equations. 32 to the x equal 4. By this point of this unit, when you see 32, you start thinking what? That's 2 to the 5th. That's what you got to have the mindset. This is 2 to the 5th raised to the x, okay? Now, this is equal to, is there any way I can write 4 as a power of 2? It's what? 2 squared. So I've got 2 to the 5x equal 2 squared. Do I have the same number on both sides raised to a power? Yeah, these exponents are what? They are equal to each other. 5x is equal to 2. X is equal to what? Yeah, x is equal to 2/5, okay? So your strategy in solving these, get the same number on both sides. So you get 2 to a power equal 2 to a power, and then and only then are the exponents equal, okay? I mean, I can't write, you can't have 2, sorry. If you had something like 2 to the x equal 3 to the 4th, you can't say that x equal 4 here, okay? That doesn't follow. But if I had 2 to the x equal 2 to the 4th, it follows that x has to be 4 in this case, okay? That's what we're trying to, get problems that look like this. If it looks like this, there's nothing I can do. Okay? So let's keep on going. 2 times 3x equal 18, okay? Now, on the left side, I want a number to a power. Do you see a number raised to a power? You see 3 raised to the x, okay? But it's not by itself. What could I do to get it by itself? Yeah, divide by 2. And then I get 3 to the x equal what? 9. Now, I want the same number on both sides raised to a power. You look at 9 and you know that 9 is what? 3 squared. So 3 to the x. Yeah. So I've got the same number on both sides. So what's the solution? Yeah. X is equal to 2. Okay? What do I do on this one to get the exponential all by itself? Yeah. Subtract 5 from both sides, and I get 2 to the x equal 8. Now I want to see, can both of those numbers be written as powers of the same number? Yeah. So 2 to the x equal 2 cubed. Therefore, x is equal to what? 3. Okay. Okay. Those are too easy. Those were the warm up. We need to get a little bit more. 3 to the x plus 1 equal 9 to the 4x minus 7. No, you cannot do that. That's called bad math. You can't divide by 3. It's not 3 multiplied, it's 3 to an exponential. So my goal is, there are two numbers I'm looking at. I'm looking at a 3 and a 9. Is there any way both those numbers can be written as powers of the same number? Yes. 9 is equal to what? 3 squared. So I can write this as 3 to the x plus 1 equal 3 squared to the 4x minus 7. Okay? So now I get 3 to the x plus 1 equal 3 to the 8x minus 14. Okay, that's just algebra 1 stuff right there. 2 times 4x minus 7 is 8x minus 14. Okay, algebra 1 is coming back to you now. Now, do I have the same number on both sides raised to a power? Yeah, it looks more complicated, but all this means is those things have to now be equal to each other. So if x plus 1 equal 8x minus 14, if I subtract x from both sides, I get 7x if I add 14 to both sides. So that's 15. 15 is equal to 7x, therefore x is equal to what? (15/7). So remember when we started out, we had a problem like 2 to the x equal 4. You could just look at it and say x is 2. These problems are not that hard, but I can't just look at that and say, oh yeah, x is 15/7, okay? But when you go through the algebra, it's not that tough, okay? Same process, same number. You want to try to get the same number on both sides raised to a power. I've used 2's and 8's too much because this one's pretty easy. 2 to the 3x equal 8 to the 4th. What number, I'm seeing what number on the left that I'm worried about? I'm worried about, so I've got a 2 that I'm raising to power. What number's on the right? An 8. Is there any way a 2 and an 8 can be written as powers of the same number? They're all powers of 2. So this is 2 to the 3x equal 2 cubed to the 4th power. So 2 to the 3x equal 2 to what power? 12. That means that 3x is equal to 12. Yeah, so x is 4. Okay. Okay, see, pretty straightforward. Now they get real easy, okay? So, just, you can do this. Okay. Now, here's the way I look at a problem like this. What number do I see on the left raised to a power? 81. What do I see on the right? 9. 9 and 81, can they be written as powers of the same number? They can be written as powers of 9. They can also be written as powers of what? 3. But I'm going to, if it's powers of 3, then I got to work on this side and that side. If it's powers of 9, which side do I need to work on? Just left. Which one do you think I'm going to do? Powers of 9. So I'm going to write this as 1 over 9 squared to the 2x is equal to 9 to the 13 minus 5x. So this is 1 over 9 to the 4x equal 9 to the 13 minus 5x. Now, do I have the same number on both sides raised to a power? Not exactly. What could I do to get them both saying 9 to a power? Yeah. I can make this positive exponent a negative exponent. So I can write this as 9 to the negative 4x is equal to 9 to the 13 minus 5x. Okay? So again, what we have been doing so far in this unit, we have been starting with something like this, and you knew to write that as 1 over 9 to the 4x. Now you need to be able to look at 1 over 9 to the 4x and say, I really need that to be 9 to the negative 4x in order to work this problem. Now do I have the same number on both sides raised to a power? Yeah, those things have to be equal now. So negative 4x has to equal 13 minus 5x. If you add 5x to both sides, you get x equal what? How about 13? Okay, yes. Okay. Mm-hmm. Okay. Let's look at a few more. They just keep getting easier and easier, okay? Now this one you got 9 to the x squared. You've got 9 to an exponent to an exponent. That just makes it more fun, right? Okay. Now, if you look at these numbers, the main thing I key off when I first look at it, I've got a 9 and a 3. Can I write those as powers of the same number? Yes. Yeah, they can all be written as powers of 3. So I can write this as 3 squared to the x squared power equal 1 over 3 to the negative 7x minus 4. So this is 3 to the 2x squared equal, how can I write this as 3 to a power and not 1/3? The negative exponent becomes I just flip the sign of the exponent. So this is 3 to the 7x plus 4. Does everyone see how I got there? Okay. So I just changed the sign of the exponent. Now do I have the same number on both sides raised to a power? Yes, that means that this has to equal this. Okay, so 2x squared has to equal 7x plus 4. That is what kind of equation? It is a quadratic equation. We like to solve quadratic equations by setting them equal to 0. So this is 2x squared minus 7x minus 4 equals 0. Now, Henry's just looking at me like, are you okay? You're good? Okay. Okay. Now, in order to solve this, we're looking for two miracle numbers that possess what properties? Multiply to -8, add to -7. Okay. What numbers multiply to -8 and add to -7? Yeah, -8, +1. I will use these two numbers to rewrite this equation so that I can factor by, starts with a G, grouping. Okay. So this is 2x squared minus 8x plus x minus 4 equals 0. And then I will look at this 2 by 2. So what can I factor out of the first two? Yeah, 2x times x minus 4 plus x minus 4 equals 0. Therefore, 2x plus what? Plus 1 times x minus 4 equals 0. This means that x is equal to what? -1/2 or +4. So I got two answers for this one. Okay. So once I got to here, this was last semester's problem. Okay. That's this semester's problem right here. But once you got it to here and you set the exponents equal, you came up with a quadratic equation. So we always want to keep that skill handy because the next unit is polynomials and factoring. Those quadratics will come back with a force next unit. Okay? I believe this is the last one. Okay? Pardon me? What negative? Well, let's look at it. So what's hard about this one that I haven't seen before? Fractions. Okay? But you just break it down. I got 2/3 here. That's all that I mean, 2 can only be written, it can't be written as powers of any other number. 3 cannot, they're prime numbers. But then I've got a 9 and a 4. A 9 can be written as what? 3 squared. A 4 can be written as 2 squared. That's going to be my key, okay? So 2/3 to the 2x is equal to 3 squared over 2 squared to the x plus 1. Okay. I'm going to write this as then 2/3 to the 2x is equal to 3/2 to the 2 times x plus 1, right? Everyone agree with that? Okay. Now, do I have the same number on both sides raised to a power? Almost, okay? What would need to happen for them to be the same number? One of these has to flip. It doesn't matter which one. When I flip it, what do I do with this exponent? Make it negative. So I can just flip this one on the left and make it negative, or I can do the one on the right. It looks easier to do it on the left to me. So I'm going to write this as 3/2 to the -2x is equal to 3/2 to the 2x plus 1. Do I have this? Pardon me? 2x plus 2? Yeah. Yeah. That's what that'd be the next step, or you could have already done it. So now I've got the same number on both sides. These exponents must be what? They must be equal. So -2x is equal to 2x plus 2. So if I subtract 2x from both sides, I get -4x is equal to 2. X is 2 over -4, or what? Yeah, -1/2. Okay? Okay? Is that all right? That's all it is. So it's the exponent is the variable. The only way you can solve any of these is just to get both sides of the equation. It's the same number. So if I look at this one, they're both going to be powers of what? 5. This is going to be what? 7, and then 49 is going to be 7 squared. Okay? If I look at this one, 32. When I look at 32 now, you should already know in your head that's 2 to the 5th, okay? So this is going to be, that's 2 cubed. So I'm going to have to flip something. So it's going to be powers of 2. Now what about this one? Yeah, this is a power of 3 and that's a power of 3. Now it doesn't help me that this is 3 times 9. It's not a factor of. It has to be a power of, okay? So 27 is not a power of 9. 9 times 3 equals 27, but 27 is a power of 3. So both, this has to be written as 3 squared, that has to be written as 3 cubed to get through that one. If you look at the next one, well, that's a power of 4. This is also 4 cubed. This is a 3, that's 3 to the 4th. So that's what you're going to use to work through and to get your answers on these. Okay? You've got